Alright, so I'm going to jump into section 5.5 this morning, and section 5.5 is starting to make that bridge between intermediate algebra and college algebra. I don't think the math in Math 151 college algebra is significantly harder than it is in intermediate algebra, but the big difference is within one section you might have 2 or 3 different styles of problems, maybe sometimes 4 different styles of problems. A lot of times in Math 120, each section has 1 or 2 styles of problems, and it's just the more variety of problems that will make college algebra a little bit harder than intermediate algebra for some of you, but the math isn't harder. This section basically has 3 styles of problems. The first style of problem, we did something just like it or really close to it in section 4.9, so these might be easy for you. For these problems, I want to first, as much as possible, get the square root term isolated. Then I'm going to square both sides, and I'm going to wind up having to factor to solve. And I know we did something just like number 2 when we did section 4.9. The numbers in this problem might get a little bit big for the factoring part of this problem, but this isn't anything new at all. The next few problems I'll do, they'll be a little bit different because this first step, are when I square the square root, it's going to be a little different. So I'm squaring both sides to get rid of the square root. On the left side, squaring gets rid of the square root symbol. On the right side, I have to FOIL, because if you're squaring something that's squared and it's a binomial, when you write it without the exponent, you can see the squaring. So on the right side, I need to do firsts, which are y times y, which are going to be a y squared. Outers, which are y times minus 12, which is a minus 12y. Inners, another minus 12 times y, which is another minus 12y. And lasts, minus 12 times minus 12 is a positive 144. So I generally combine my outers and my inners, and I'll do that here. And I can make the right side y squared minus 24y plus 144. Because I have a square and an equal sign, I'd like to solve by factoring. I need to get the problem set equal to 0 for the factoring to work, and I need to subtract y from both sides to get the 0. The y that I'm subtracting has a 1 that's implied in front of it, so if I show it on this side, you can see maybe better how to simplify. So here I have a minus 1 and a minus 24. Since those numbers have the same signs, I'm going to add them and keep them negative. So the right side is going to give me y squared minus 125y plus 144. So I could solve that by factoring, but 144 is an unpleasantly large number, and I have 2 other strategies for solving problems that are equal to 0 that have a squared term. The C method, completing the square, which I don't really ever pull out of my hat, or the quadratic formula. So instead of factoring like I did in chapter 4, I'm going to pull out the quadratic formula. So this is part of knowing multiple strategies to solve a problem and using the one that you think best fits the problem. Because 144 is such a large number, I couldn't just immediately think of factors of 144 that are going to help me get a 25. So I'm using the quadratic formula to solve this equation. And in the quadratic formula, the a is the number in front of the y squared term, which is 1. The b is the number in front of the first power term, which is negative 25. And the c is the number without the letter. So I'm going to go y equals negative from the formula, and then negative 25 from the b, and then plus or minus the square root of negative 25 squared minus 4 times 1 times 144 4, not that that's probably that readable, all over 2 times 1. I'm going to bust these out on my calculator. I'm going to just enter a positive 25 there rather than doing the double negative. So I'm going to go, I'm in a table mode. To get out of table mode, I just hit the mode button. I'll do 2 for complex because just in case there's an I. So fraction, I'll do the double negative, make it a positive 25, and then plus square root parentheses negative 25 squared minus 4 times 1 times 144 over 2 times 1. That gives me y equal to 16 for one of my answers. And I'm going to back up, change the plus sign to the minus sign, and get the other answer of 9. On these problems, more so than any, if you don't check, you could be falling into the trap of writing down an answer that doesn't check. It isn't an answer. So I'm going to go ahead and write in this column and do my checking. The original problem said the square root of y equals y minus 12. To check 16, I'd go the square root of 16 equals 16 minus 12. This is something I can do without a calculator, but if you need to use your calculator to simplify, you can. Square root of 16 is 4. 16 minus 12 is 4. So 16 is a solution. Now I'll do the same thing for the 9. I'm going to go the square root of 9 equals to 9 minus 12. On the left side, the square root of 9 is 3. On the right side, 9 minus 12 is negative 3. So 9 isn't a solution. So when I go to write my answer, probably the best answer is just to say y equal to 16. If you want to, because you're proud of finding that 9, you could say y equal to 16, y equal to 9. Either the words is extraneous or does not check. Is extraneous means doesn't check. It's an extra solution that the algebra gave me. So that's completely not new. Problem 2 is kind of easing us into the newness of section 5.5. The big difference in the next few problems it's going to be the side with the square root, and it's not going to be that hard, hopefully, to deal with. So that's everything for that problem. In problem 4, my instructions say isolate the term with the square root. I'm going to do that first. I'm going to get the term with the square root to be the only thing on the left-hand side. So to make that happen, isolate the square root term first. I'm going to minus 2y and add 3 to get started. If I do that to the left side, I have to do it to the right side. On the left side, when I minus 2y and add 3, I still have the 5 square root of y part. And on the right side, since there was a 0 on that side to start, the minus 2y and plus 3 just stay there on that side. I couldn't use the quadratic formula to solve number 4 because it doesn't have a squared term. In section 4.9, when we had numbers outside the square root, we were able to divide by those numbers, and that dividing didn't produce a fraction, so those problems were one step easier. This problem, if I started dividing everything by 5, I'd get 3 over 5 and negative 2 over 5. I don't want the fraction, so I'm going to isolate the square root, but not completely like I was able to do in the last section. In this section, I'm going to square to get rid of the square root while there's still a number in front of the radical. And that's the part that makes this a little bit tricky. And each side square differently. The left side, because there isn't a plus or minus between the 5 and the square root of y, I can just square the individual terms. The right side, the plus sign forces me to FOIL to square. So on the left side, to simplify, I'm going to go 5 squared and the square root of y squared. And you can only square like that when there isn't a plus or minus inside the parentheses. 5 squared is going to be 25. And then for the square root of y squared, when you're squaring a square root, the square root cancels out, and you get just a plain ordinary y. On the right side, I'm going to expand and FOIL. First are going to be minus 2y times minus 2y, which is a positive 4y squared. Outers are minus 2y times 3, which is a minus 6y. Inners are 3 times minus 2y, which is a minus 6y. Last are positive 3 times positive 3, which is positive 9. Just like the last problem, the outers and the inners don't cancel because they have the same signs. I add the 6's and keep them negative. So squaring both sides gives me 25y equals 4y squared minus 12y plus 9. Now I have a problem with a square. I'd like to solve by either factoring or the quadratic formula, but both the factoring method and the quadratic formula method require the problem to be set equal to 0. So I'm going to get it set equal to 0 and do 4y squared minus 37y plus 9. This is bottoms up factoring. Bottoms up factoring is easy for me, but I'm going to assume that you probably prefer the quadratic formula to the factoring. So I'm going to use the quadratic formula to solve. I'm going to go a equal to 4, b equal to minus 37, c equal to 9. I'm going to go y equals negative b, which is going to be negative of negative 37, plus or minus the square root of b squared, which is negative 37 squared, minus 4 times a, which is 4, times c, which is 9, all over 2a, which is 2 times 4. So I'm going to do these on my calculator because it's so much easier for me. This double negative I'm going to make positive. So I'm going to go 37 plus square root of negative 37 squared minus 4 times 9 over 2 times 4, and get 9 again. Get one answer of y equal to 9, and then back up, change that plus to a minus, and get another answer of 1/4. The 1/4 is not pleasant to check without my calculator, but with my calculator it shouldn't be that hard to check. So before I write answers, I'm going to check each. So for the checking part, I have to use the problem before I did anything to it. The original problem was 2y plus 5 square root of y minus 3 equals to 0. First I'll do the 9. I'm going to go 2 times 9 plus 5 times the square root of 9 minus 3. And when I do that, I better get 0 if 9 is a solution. So first check 2 times 9 minus 5 times the square root of 9 minus 3. That's the left side. I get 0, so 9 is definitely a solution. And I'm going to include it in my answer. It could happen that 1/4 also works, but I bet it doesn't. So the next thing I'm going to do is 2 times 1/4 plus 5 times the square root of 1/4 minus 3, and see if that equals to 0. So 2 parentheses fraction 1/4, finish up my parentheses, plus 5 times the square root of fraction 1/4 minus 3. I need the minus 3 outside my radical, minus 3. And it worked too. So I kind of remembered that happening. So this is kind of rare for these problems with the square roots that both numbers check. So in my answer, I just need to write both the numbers. There isn't an extraneous solution for this problem. So it can happen that when you're solving these problems that start off with square roots, that both numbers check. Usually it happens that one number checks and the other doesn't. Sometimes neither number checks. So anything can happen when you're solving a problem that starts with a square root and you're squaring to get rid of the square root. 6 is similar to the last problem in that it has a square root that I need to get isolated. And in the last problem, I kept the square root on the left side and got the letter and the number without the square root on the right side because it didn't, overload me with negatives. On this problem, if I did the same thing in minus b and minus 2 from both sides, there'd be a minus in front of the b, the square root, there'd be a minus in front of the b and the 2. It's more efficient in this problem, or it's probably easier to add the square root of 3 times b to both sides, and that leaves everything positive. You'll get the same answer if you minus b and minus 2 from both sides, but then you'd have negatives. You'd have 3 negatives to deal with. What I did made me have no negatives to deal with, so this is probably a better strategy. So just like we did in section 4.9, just like I did for the second problem, I wanted to get the square root isolated. In section 4.9, the number in front of the square root, when we divided it, it just didn't produce any fractions. If I divided both sides by 3, I'd get b over 3, and I'd get 2/3. I don't want to get the fractions, so this is as far as I'm going in terms of isolating the square root. And now I'm going to square both sides. The left side, because of the plus between the terms, is going to need foiling. So I'm going to do b plus 2 times b plus 2. Firsts are going to be b times b, which is b squared. Outers are b times 2, which is 2b. Inners are 2 times b, which is another plus 2b. Lasts are 2 times 2, which is a plus 4. So when I FOIL the left side, I get b squared plus 4b plus 4. On the right side, I have to square the 3 and square the square root. When you square the 3, you get a 9, and squaring cancels out the square root, leaves me with a b. So squaring each side, the left side simplifies to b squared plus 4b plus 4. The right side comes out to 9b. I'm going to get the problem equal to 0 by minusing 9b from both sides. That leaves me with b squared minus 5b plus 4 equals to 0. Those numbers, this problem I could factor, and if something is easy for me to factor, I'm going to factor instead of using the quadratic formula, because the quadratic formula I do slower. So because I know how to factor this quickly, I'm going to solve this by factoring. If you aren't comfortable factoring, the quadratic formula will work just fine because the problem has a squared and it's equal to 0, so it's kind of set up for the quadratic formula. But I factored it. You'll get the same answers using the quadratic formula than you would factoring, so that there's no danger into using one method over another. So I factored into b minus 1 times b minus 4. Once I had the factors, I set them equal to 0. Finished it up and got b equal to 1 and b equal to 4. I absolutely have to check. The problem before I did anything was that I'm going to check 1 first, see if 1 minus 3 times the square root of 1 plus 2 equals to 0. That one I think works, but let me double check it. So 1 minus 3 times the square root of 1 plus 2. That one definitely works. I get 0 equal to 0, so 1 is a solution. The other solution I came up with is 4, so I need to check, is 4 minus 3 square root of 4 plus 2 equal to 0? I think that one checks too. 4 minus 3 square root of 4 plus 2 plus 2. That one also works. So on the more complex problems here, both the solutions worked, and that's not guaranteed to happen on the test. On the test, more often than not, you get one solution checks and one doesn't. And I'm not sure what happens in the homework for these. So problems 1 through 6, there's the only thing that was new about them is knowing when to stop isolating the square root and having the square a little bit differently than we did in 4.9. But these problems I could have even put in section 4.9 and they would have fit nicely in there. But decided to put them in chapter 5 just because I wanted you to remember them and see them twice. Sometimes seeing a style of problem a second time makes it sink in, and you'll see these in college algebra. The next style of problems all have parentheses, and there are at least 2 ways to solve each problem, and the way that we solve the problem is going to almost feel illegal, but it is a legal mathematical strategy and a really powerful mathematical strategy that you use a bunch in calculus. It's called U-substitution, and basically U-substitution has me create a problem that's simpler than the original problem. I'll solve the easy problem and use the answers to the easy problem to help me generate answers to my problem. So my steps for all the problems between numbers 1 through 19 is first, I'm going to change the parentheses to a u. So in this problem, I'm going to change the x minus 5 in a parentheses to a u. So what I'm going to do on the left side is this x minus 5 and the parentheses, I'm going to make a u. I'm going to leave the exponent of 2. This x minus 5, including its parentheses, I'm going to change a u to a u. That problem for me is less complex than the original problem. So I like it a bit. And then after I make that change, I'm going to solve the equation with the u. This problem has a square, so I could either solve by factoring or the quadratic formula. The factoring is easy for me, so I'm going to factor it. I go u plus 7 times u minus 1 equals to 0. So finishing up solving the u problem, I go u plus 7 equal to 0, u minus 1 equal to 0. For the u plus 7, I minus 7 from both sides and get u equal to minus 7. For the u minus 1, I get u equal to 1. Unfortunately, those aren't answers for the original problem. If I tried to check negative 7, if I went negative 7 minus 5 squared plus 6 times negative 7 minus 5 minus 7 equals to 0, that's going to tell me that negative 7 is not a solution. So I'll just show you that the u answers, although I finished solving a problem, the answers that doing this strategy with don't work in the original problem. So when I plugged in 7 for the x's in the original problem, I get 65 equal to 0. 7's not a solution. Similarly, if I did 1, if I did 1 minus 5 squared plus 6 times 1 minus 5 minus 7 equals to 0, I'm also going to be left with something that's not a solution. So I did 1 minus 5 squared plus 6 times 1 minus 5 minus 7. I get negative 15 equal to 0. So it seems kind of pointless at this point. I've generated answers, but they don't check. Step 3, get the answers that will check. How do I do that? I solve the inside of the parentheses, x minus 5, equal to the u's. So the U method doesn't give me something that checks. To get something that checks, I have to take what's inside the parentheses, in this case x minus 5, and set it equal to the u's. I have two u's, so I'm going to set each u equal to an x minus 5, the inside of the parentheses, and in this case, if I add 5 to both sides for the x minus 5 equal negative 7, I get x equal negative 7 plus 5 is negative 2. And for the right one, if I do x minus 5 equal to 1 and add 5 to both sides, I get x equal to 6. Let me check these. So I'm going to go, is negative 2 minus 5 squared plus 6 times negative 2 minus 5 minus 7, is that equal to 0? Hopefully it is, because I think it's supposed to be the answer. So negative 2 minus 5 quantity squared plus 6 times minus 2 minus 5 minus 7. So negative 2 actually is a solution, because when I plug it in, I get 0 equal to 0. And now let me check the 6. I'm going to go 6 minus 5 squared plus 6 times 6 minus 5 minus 7, and see if that equals to 0. So I'm just taking the numbers, plugging them into the original problem, and now I'm busting out my calculator. So 6 minus 5 squared plus 6 times 6 minus 5 minus 7, and I get 0 equal to 0 again. So the x answers work, and I'm ready to write my answer. X equal negative 2 and 6, and I've checked them to make sure they work. You don't ever need to check the U answers. The U answers almost never work, and if they work, it's just a fluke because the U answer turns out to be the same as one of the X answers. So each one of the problems between 11 and 19 has two parentheses with the same contents. When that's the case, when you have a problem that has multiple parentheses with the same contents, you could take the contents of the parentheses, including the parentheses, and change them to a U, solve a problem that's similar but less complex than the original problem with U's, and you can use the U answers to obtain your X answers. So I'm going to do that for each of the problems coming up here for 14, 16, and 18. So 14, structurally it's the same kind of to me. It has unpleasant factoring. So what I'm going to start off, first of all, I see two identical parentheses. I'm going to change the entire parentheses to a U. So for the first piece, this entire x minus 1 I'm going to change to a U, and give me 3u squared. The second piece, I'm going to get a 4u. The third piece, I'm going to get plus 1 equal to 0. I need to solve this. This is bottoms up factoring. I don't want to do bottoms up factoring, so I'm going to use a quadratic formula. But you could use bottoms up factoring. So I have a equal to 3, b equal to 4, c equal to 1. I'm going to go u equals negative b, which is going to be negative 4, plus or minus the square root of b squared, which is 4 squared, minus 4ac is 4 times 3 times 1 over 2a is 2 times 3. Like using my calculator on these, so I'm going to do that. So fraction negative 4 plus first square root of 4 squared minus 4 times 3 times 1 over 2 times 3. Yeah, that gives me u equals to negative 1/3. And now I'm going to change the plus to a minus. And I get u equal to negative 1. More than likely, neither one of those answers is going to check because I want answers for x. So first I changed to a u, and then I solve for u, and then I set the u answers equal to the inside of the parentheses. So first step, change the parentheses to a u, solved for u, and now I'm going to change the u, set the u answers equal to the inside of the parentheses. The inside of the parentheses is x minus 1. And I'm going to solve these. So for the fraction 1, I have to add 1 to both sides. Left side is easy. Right side, I don't feel like adding negative 1/3 and 1, so I'm going to do it on my calculator. I'm going to go negative 1 over 3 plus 1. My calculator is so nice and tells me that that's 2/3. Saved me having to work with fractions. And then this one, I go plus 1 plus 1. I get x equal to 0. I'm going to check both of them. You don't usually get extraneous solutions when you're working with the u method, but I'm going to check. So I'm going to go, in the original problem, 3 times 2/3 minus 1 squared plus 4 times 2/3 minus 1 plus 1, and see if that equals to 0. So first check, 3 parentheses fraction 2/3 minus 1 parentheses squared plus 4 parentheses fraction 2/3 minus 1 plus 1. Hopefully I see a nice 0, and it works perfectly. So 2/3 is a solution. And then let me do the 0. I'm going to go 3 times 0 minus 1 squared plus 4 times 0 minus 1 plus 1. And see if that equals to 0. That one I really don't need my calculator for, but I have it and it's quicker. So 3 times 0 minus 1 squared plus 4 times 0 minus 1 plus 1. And I get 0 again. Again, if you're checking your answers, you're not ever going to write down a wrong solution. I'll show you this one. For this ugly u didn't work. If I tried to check that, if I tried to go 3 times negative 1/3 minus 1 squared plus 4 times minus 1/3 minus 1 plus 1. So if I stopped at my u's and did this, I would have 3 times fraction negative 1/3 minus 1 squared plus 4 parentheses fraction minus 1/3 minus 1 plus 1, and I'd get 1 equal to 0. And that's not true. So negative 1/3 isn't a solution. Negative 1 also isn't a solution. The u's are generally not solutions unless something freaky happens and the u and the x come out to be the same. That was disgusting. But that doesn't normally happen. The u method doesn't generally produce extraneous solutions. So, but I always check. If I have a problem with an equal sign, my calculator makes it so easy to check that there's no reason to skip the checking. Okay, 16. Much harder problem in some sense, but still structurally the same. There's 2 parentheses with the same contents, and that's the time I like to do u's. So I'm going to let u equal to this entire x squared minus 1 parentheses. So I'm going to dump out that x squared minus 1 parentheses, be left with a u squared. Dump that x squared minus 1 parentheses, be left with the 5u. So I get u squared plus 5u plus 4 equal to 0. That's a baby problem in terms of factoring, so I'm going to solve it by factoring. I'm going to go u plus 4 times u plus 1 equals to 0. And then I do u plus 4 equal to 0 and minus 4 from both sides and get u equal to minus 4. And then I do u plus 1 equal to 0 and I minus 1 from both sides and get u equal to minus 1. So I replace the parentheses with a u. solve the u problem, and then I'm going to set the inside of the parentheses equal to the u. -4 and -1 aren't likely solutions to this problem, so I'm going to go x squared minus 1 equals -4, and x squared minus 1 equals -1. So I'm going to solve for x's by setting the x equal to the u answer. I'm going to get a really unpleasant answer to check, but I'm going to check it anyways. So first one, I'm going to get -3 equal to x squared. That's not enough for x. I have to now square root plus or minus square root. The square root of x squared, the square rooting cancels out the square, leaves me with the x. On the right side, the square root of -3 turns into square root of 3 times I. If I did square root -3, I get square root of 3 times I. And I need a plus or minus. Anytime I introduce a square root into a problem that didn't start with 1, I need a plus or minus. The other side, I plus 1, I get x squared equal to 0, and then I square root plus or minus square root. To do the square root of 0, it's 0, and when I get x equals plus or minus 0, plus 0 is just 0, and -0 is -1 times 0, which is also just 0. So this just gives me the 0. Now I have 3 unpleasant things to check, but I'm going to check them all. So first I'm going to check x equals the square root of 3 times I. And remember the original problem. That's what I have to check into. X squared minus 1 quantity squared plus 5 times x squared minus 1 plus 4 equals to 0. Not as nice of a thing to check, but I should be able to do it. So you have to be in complex mode too. So if you didn't hit mode and then 2, the check is going to give you an error. So mode and then 2 for complex. Now checking parentheses. Oh, let me write down what I'm checking. Parentheses, the square root of 3 times I squared minus 1 squared plus 5 times parentheses, the square root of 3 times I squared minus 1 plus 4, and that should equal to 0. The i's have to be outside the square roots and not under the square roots. So first one, I'm going to have a double parentheses, and then square root of 3, arrow out of the square root, hit the ENG button for the I, close my parentheses and square it. So it looks just like this, minus 1 parentheses squared. So that looks just like the first parentheses. You're going to stop seeing that first parentheses in a second here. So plus 5, double left parentheses, square root of 3, arrow out of the parentheses, ENG button for the I, close my parentheses, square, minus 1, close the parentheses, and then plus 4. And it gives me a 0, so I get 0 equal to 0. So I know that checks. The nice thing is, when I go to check the x equal negative square root of 3i, I can just go into the line that I just entered and put a negative right in front, inside the second parentheses here next to the 3's. So to check this one, I've done all the work, the grungy work. I'm just going to back up and get right to the left of that square root of 3, put a negative in, and in the first parentheses as well, I'm going to get right to the left of the negatives, right to the left of the square root of 3 and insert a negative. Now when I hit enter, I've checked the negatives, the square root of 3i, and it works. And the last thing I need to check is 0. That's much easier to check. So I'm going to go, is 0 squared minus 1 squared plus 5 times 0 squared minus 1 plus 4, does that equal to 0? I could probably check that without a calculator. Let me clear this and use my calculator. So 0 squared minus 1 all squared plus 5 times 0 squared minus 1 plus 4. And I get 0 equal to 0. So all three answers check. And I'm going to write my answer just how it looks above. Answer x equal to 0 in plus or minus the square root of 3 times I. In terms of the test, the first couple problems I did with the U, these are definitely test worthy. This problem, because it gets I's within U's, I probably wouldn't make that a test question. And 18 also, I probably wouldn't make a test question, but I can do these. The nice thing about U's is they could take problems that are really complex and make them not so hard. So, but they're limited in their use. You have to have a problem set up just perfectly. And I do have in these problems, the middle grouping of problems, they're set up perfectly for the U method. In calculus, you'll learn other methods, other kinds of problems that can be solved with U's. That look different than this, but the U strategy will still work. So I'm going to change this to U squared plus 5U plus 6 equals to 0. And again, this is baby factoring, so I'm going to solve it by factoring. I'm going to make this U plus 2 times U plus 3 equals to 0. U plus 2 equal to 0 and U plus 3 equal to 0 is the next thing I needed to do. For the U plus 2, I minus 2 from both sides and get U equal to minus 2. That likely won't check in the original problem. And for the U plus 3, I'm going to minus 3 from both sides and get minus 3. The hard part of this is pulling out of your head how to do what I have to do next. After I solve for U, I set what's inside the parentheses equal to the U's. And this is part of what makes college algebra tough. Because in the middle of doing a problem, I'm going to be expected to pull things out of my mathematical bag of tricks to help me finish when I might have not done those things in a while. And this is the kind of thing that came up in chapter 2. This is the kind of problem I'd like to solve by cross multiplying. I don't have any squares, so I don't need factoring. I have a fraction, and I like when I have fractions and equal signs to solve by cross multiplying. So I'm going to set these up to solve by cross multiplying. Again, the chances of this making it onto your test are really minimal. The first two U problems are definitely test worthy. These not so much. But good to see, just because if you're going to Math 151 next or 150, it's nice to just see some things that might pop up and how they might pop up. So I cross multiplied down and up. I get 1 times x minus 3 equals 2 times negative 2. That gives me x minus 3 equals negative 4. And then I plus 3. This gives me x equal to negative 1. For the other one, I get x minus 3 equal negative 6. And I plus 3 and get x equal negative 3. This is one of those rare instances where a U answer matches an X answer. So the negative 3 actually would have checked, but that's just a fluke. That rarely happens. So now I need to check. And I'm going to check into the original problem. First thing I'm going to check is x equal to negative 1. I'm going to go to the original problem and see if negative 1 minus 3 over 2 squared plus 5 times negative 1 minus 3 over 2 plus 6, and see if that equals to 0. Again, without this calculator, I wouldn't be so into checking. But because by hand, a lot of times the checking by hand is harder than doing the original problem. But this calculator makes checking easy in some sense, which is so nice, because anytime you have a problem with an equal sign, you can avoid making a mistake if you check your answers. So when I plug the -1 in, it's simplified to 0 equal to 0. Now I'm going to plug the -3 in, and the nice thing is I'm just going to use what I've just typed in and not type this whole thing in again, and I'm just going to change the -1 to a 3. So I'm just going to back up, first parentheses here that I had the -1, delete the -1, change it to a -3, go into the other parentheses, delete the -1, change it to a -3, and I get 0 equal to 0 again. So the answer to this is x equal -1 and -3. So the square rooting in the first group of problems often produces solutions that don't check. The U problems rarely produce solutions that don't check. Usually if you don't make a math error, the solutions are going to check. The last group of problems, the only ones that you're responsible for are the ones with the x to the fourth, or the x to the fourth and the x squared. So if you want to, you only really need to solve the problems with the x to the 4/x squared. So for the even problems, if I look at problem 20, it has an x to the fourth and x squared. That's test worthy. If I look at problem 22, well, it has an n to the fourth and n squared. So it doesn't matter what the letter is. That's also test worthy. And then once we get beyond that, when we have exponents that aren't 4 and 2 in the bottom grouping, for 24, 26, 28, those three problems, those, if you don't watch me do those, it's not such a big deal. Maybe I'll just do 24 and I might not even do 26 and 28. They get a little bit subtler, and they're probably more appropriate for college algebra than they are intermediate algebra because of some of the stuff that comes up in them. So if you just watch me do 20 and 24, 20 and 22, and you do probably problems 21 and 23 in this bottom grouping, you'll be okay for the test. I'll go ahead and do one extra problem, just because I can, and it's good for you to see. But again, if you just only did 20, 21, 22, and 23 in this bottom section, you should be fine. The instructions tell me to solve by factoring, and this is odd in some sense, because usually I don't factor when I have an x to the fourth. It turns out that anytime the exponents are a multiple of 2 apart, if you take the middle term's exponent and multiply it by 2, if that equals the first term's exponent, then it's set up for factoring just fine. So I'm going to factor this. I can't use the quadratic formula because the quadratic formula doesn't work when you have an x to the fourth. So I'm going to solve it by factoring. The only difference between factoring this and factoring like we normally do is the first term can't just be an x, it has to have whatever exponent the middle term has. So my firsts have to be a couple of x squareds when they're normally just a couple of x's. My lasts need to subtract, multiply to -4 and add to 3. They're going to be +4 and -1. So that really isn't that different than factoring like y squared plus 3y minus 4. If you factored that, you'd get y plus 4 times y minus 1. The only difference in factoring when you have exponents that aren't traditional is as long as the exponents are a multiple of 2 apart, the middle exponent times 2 equals the first exponent, then that middle term with its exponent goes the first in the parentheses. So now that I have the problem set equal to factored and set equal to 0, I'm going to split my factors up, set each one equal to 0, and now this looks like something that could have been in section 4.1. I'm going to solve with square roots by isolating the squared term and then square rooting plus or minus square rooting. So I want to get answers for x's, not answers for x squared, so I need to solve for x's. So I square root plus or minus square root. For each of the x squared, square rooting cancels out the exponent, and then I need to do the square root. On the -4, I get 2i and -2i. On 1, I get 1 and -1. Let me check each of these, because I always should check. These are going to take a lot of room to check. So first I'm going to check positive 2i. And then I'll do -2i. So I'm going to go, is 2i to the 4th. I don't know if my calculator can do that, but we'll try. It might die on me right now. I almost think it doesn't know how to do I to the 4th power. Let me try this, and hopefully my calculator doesn't mess with me. If it does, I'll help. Well, I don't know if I can help you. I'll try to help you, but I'll. So I'm a little bit worried right now that my calculator is gonna just not like that. With i's and the fourths, I don't know if I can do it. But I hope. So that's plugging positive 2i in, and it gives me it doesn't know how to do I to the 4th power. Well, it means I have to do a little bit by hand. So 2i to the 4th, let me just make it a little bit easier. So my calculator can't handle this 2i to the 4th, so I'm going to do it for it. So and the way you have to do this by hand is expand it. I'm going to multiply these two parentheses. 2i times 2i is 4i squared. And then this parentheses, 2i times 2i, is 4i squared. 4i squared is 4 times -1. So this is 4 times -1, which is -4. This is 4 times -1, which is -4. So I'm going to get 16 plus 3 times 2i squared minus 4 equals to 0. So I'm really unfortunate, but my calculator, for whatever reason, it's not programmed to do I to the 4th power. It gives it an error. So I did this part that's giving it an error by myself. I wrote 2i to the 4th as 4 2i's being multiplied, grouped them into pairs. First 2i times 2i is 4i squared. Second 2i times 2i is 4i squared. 4i squared is 4 times -1, because I squared is -1. So 4 times -1 is -4. 4 times -1 is -4. That comes out to 16. Now I'm going to do the rest on my calculator. So I'm going to go 16 plus 3 times 2i squared minus 4. And I get 0 just fine. So that is a solution. It's the first horrible solution there was to check. Now let me check the -2i. I'm going to go, is -2i to the 4th plus 3 times -2i squared minus 4 equal to 0. And I have to do the same thing with the -2i to the 4th. So I'm going to rewrite this as -2i times -2i times -2i times -2i. I'm going to multiply the first two parentheses and then the second two parentheses. First two parentheses, I multiply the -2 times the -2 and get a positive 4. I multiply the I and get I squared. Next two, I multiply -2 times -2 and get positive 4. I multiply the I and get I squared. The I squared I change to -1. So it gives me 4 times -1, which is -4, and 4 times -1, which is -4. I get 16, and then I can do the rest. Plus 3 times -2i squared minus 4. Let me see if that equals to 0. So this is one of the rare times where this calculator fails you. So let me check this. I'm going to go, I have the line above that looks just like it. So I'm going to just change that plus to a minus. magically have that. And now I get 0 equal to 0. Done checking those. If you want to roll the dice, this method of factoring doesn't usually produce extraneous solutions. And if you didn't want to force yourself to check the i's to the fourth, it'd be okay. If I want to check the positive 1, I'd go 1 to the fourth plus 3 times 1 squared minus 4 and see if that equals to 0. So 1 up arrow 4 plus 3 times 1 squared minus 4. That gives me 0 equal to 0. And I go to check the x equal negative 1. I just have to just go up in the last line and change the positive 1s to negative 1s. So backwards, change that 1 to a negative 1. Change this 1 to a negative 1. And I get 0 equal to 0 again. So I've checked all 4 solutions again. I might gamble on the i's, and if one group of solutions works, there isn't, the chances that they all work will be fine. So my answer to this problem is actually 4 answers. X equals plus or minus 2i and plus or minus 1. Let me do 22, and then I'll make up another problem with x to the 4th, just so you can get more practice on those. So this is going to have the same problem in that I'm going to get an I in my answer, and I'm going to just either I check it by hand or I don't check it, and maybe I'll try to trick my calculator. Let me wonder if I did that. I'm doing something off screen right now to see if I could trick my calculator. Oh, I can. All right. I just figured out the way we can accomplish the checking without going by hand. So again, this would be like regular factoring because the exponents are a multiple of 2 apart. The first terms have to have the exponent of the middle term. My lasts have to multiply to negative 24, subtract to be 5, or add to be 5. They're going to be positive 8 and negative 3. Really unpleasant answers here, but it's okay. So I'm going to go n squared plus 8 equal to 0. N squared minus 3 equal to 0. Let's solve each of these by getting the letter on one side, the numbers on the other. And once you get the letters on one side, the numbers on the other, you square root plus or minus square root. The square root of negative 8 reduces to 2 square root of 2i. So when I do the square rooting of n squared, you get n. And on this side, I get plus or minus 2 square root of 2 times I. On this right side, square rooting the n squared, you get n. And you get the square root of 3, which isn't reducible. So I have 4 answers to check. First, I'm going to check the horrible one. N equal positive 2 times the square root of 2i by going to the original problem and going positive 2 times the square root of 2i to the 4th plus 5 times the square root of 2 times the square root of 2i squared minus 24, and see if that equals to 0. On my calculator, I can do this for this. I can go 2 times the square root of 2 times I, 2 times the square root of 2 times I 4 times. That, for some reason, it can do. It couldn't do the 4th power, but if I enter this on my calculator, instead of having that exponent of 4, that will be enough. And again, if you just want to be lazy and not check the i's here, if you haven't made a math error, it should check just fine. So let me do this anyways. So parentheses 2 square root of 2 arrow out, I parentheses, that's 1. And now 2 square root of 2 arrow out, I close my parentheses, that's 2. And then 2 square root of 2, get out of the square root I, there's 3. 2, I needed a parentheses, 2 square root of 2 out of the parentheses I, close my parentheses. Let me just hit enter on this. This whole thing equals to 64. So rather than getting this insanely long line, I'm going to enter that on my calculator. So I did this part on my calculator. I could have just continued entering, but it's going to get so long I'm worried I was going to make a mistake. So that 2 times square root of 2 out of the 4th is 64. Now I'm going to go 64 plus 5 parentheses 2 square root of 2I squared minus 24. And that gives me 0 equal to 0. Now I want to check the negative 2 square root of 2I by making each of the 2's negative. So I'm going to do this piece. If you're clever, you'll know that you're going to get the same thing, but I'll do it anyway. So this piece is going to be parentheses 2 square root of 2, negative 2 square root of 2I, it's 1, and then negative 2 square root of 2I, that's 2, and negative 2 square root of 2I, that's 3, really, and then negative 2 square root of 2I, that's 4. I think I did 4 of them, and I could tell I was doing something wrong. Believe me, those come out to 64. So let me just do, because I think this is kind of silly in some sense, doing something that I could kind of do in my head. So I know that these compared to the one that I did first, because the 4 negative 2's are going to multiply to a positive 16, just like the 4 positive 2's, they'll reduce to the same. So I'm just going to check this line. So I'm going to go 64 plus 5 times negative 2 square root of 2I squared minus 24. It also gives me 0 equal to 0. I'm going to check the square root of 3. So I'm going to do the square root of 3 to the 4th plus 5 times the square root of 3 squared minus 24. Hopefully that equals to 0. So doing this one, parentheses, square root of 3 to the 4th plus 5 times the square root of 3 squared minus 24. That gives me 0 equals to 0. Now I'm going to change the positive square root of 3 to a negative square root of 3 and make sure that still works. So back arrow, get next to the square root, make the plus a minus, make that plus a minus, and I get 0 equal to 0. So I've checked all 4. Really was painful. So my answer to this is going to be n equals plus or minus 2 square root of 2I and plus or minus square root of 3. I'm going to make another 4th degree problem up, not from the handout, but a nice problem, hopefully. So let's extra problem. And then I'll do one more problem that isn't test worthy, then I'll be done. So I want to do enough 4th powers. If I was a gambling person, I might predict that this could be the test question. These problems, I like the solutions to be much cleaner than plus or minus 2 square root of 2I and plus or minus square root of 3. This problem, it just always pops into my head because I know it's going to have nice solutions. So let me factor this. I'm going to go x squared minus an x squared. I know that I have to have a double minus. And my last can have to either be minus 1 and minus 36, or minus 2 and minus 18, minus 4 and minus 9, or minus 6 and minus 6, because all of those multiply to positive 36. The pair that's going to give me the minus 13 is the minus 4 and the minus 9. So I get x squared minus 4 times x squared minus 9 equals to 0. I have it factored. I'm going to set each factor equal to 0. For the x squared minus 4, I'm going to add 4 to both sides. For the x squared minus 9, I'm going to add 9 to both sides. This is going to give me x squared equal to 4, x squared equals to 9, and then I square root plus or minus square root, plus or minus square root. So I get x equal to plus or minus 2, x equals to plus or minus 3. I'm going to check each one. These are easy to check. First thing I'm going to check is 2 to the 4th minus 13 times 2 squared plus 36, is that equal to 0? And then I'll change the 2 to negative 2, so clear out this junk. Parentheses, 2 up arrow 4th minus, oops, get out of that exponent, minus 13 times 2 squared plus 36. When I do that, I get 0 equal to 0, so I've just checked the 2. Instantaneously, I can check the minus 2 by just going and changing the 2's to minus 2's. So back up, change that 2 to a minus 2, change that 2 to a minus 2. So now I'm checking the 2, negative 2's. And that also gives me 0 equal to 0. So for the 2, I've worked. For the negative 2, I've worked. Now I'm going to check the negative 3. And I'm going to check the negative 3 by getting to the problem that I just typed in, deleting the 2, changing it to a 3 in both parentheses. So I'm being ultra efficient now. It's a nice kind of problem. And for the negative 3, it leads me to 0 equal to 0. Now I'm going to check the 3 by going and deleting the negatives. So I'm getting a lot for my initial entering. So I was able to check all 4 numbers in 10 to 20 seconds because I just had to insert negatives, change the number 2 to a 3, delete a negative, and I was able to check all 4. So the answer to this is x equals plus or minus 2 and plus or minus 3. Let me make up one more that's not as nice but still test-worthy. So x to the 4th plus minus 3x squared plus 4. No. This will be as nice. How about x squared plus 3x squared minus 4 equal to 0. Alright, so give that a try. Pause the video, solve it, and then watch me work it. And I'll do it. And hopefully you can check yourself. So this solves by... Oh, this is messed up. It should be x to the 4th. Let me just get a new paper here. This needs to be x to the 4th plus 3x squared minus 4 equal to 0. So the reason I'm doing so many of these with the 4th power is because I know that's what I put on the test. The other ones won't be on the test. So I'm going to factor, easy factoring. I get x squared plus 4, oh, it's so unpleasant, times x squared minus 1 equals to 0. I'll set the x squared plus 4 equal to 0, the x squared minus 1 equal to 0. For each of them, I need to get the x squared isolated, and then square root plus or minus square root. Square root of x squared is x. Square root of negative 2 is 2i. Square root of 1 is 1. If I wanted to roll the dice, if I just check the 1s and they work, I'm going to just gamble that the 2i's are going to work. So I'm going to check the 1s because they're easy to check. I'm going to go 1 to the 4th plus 3 times 1 squared minus 4 equal to 0. So 1 to the 4th minus or plus 3 times 1 squared minus 4, that is, believe it or not. That gives me 0 equal to 0. Now I'm going to change these 1's to negative 1's. So now I'm doing the negative 1. I also get 0 equal to 0. I really don't feel like doing the 4th power. Let me just do positive 2i, because I have to do the 4th power painfully slow. So I'd go as 2i to the 4th plus 3 times 2i squared minus 4 equal to 0. And hopefully it is. And that 4th power, I am really... doesn't that suck? Sorry. You've already done this, and I've already done the checking. I got the same answers. New problem. So I'm done. I'm not going to continue checking something that I just checked. This is the danger. When I make up problems, because I think like myself, I make up problems that I've already made up. That's why that one with the 13 and the 36. Oh. Well, I really want to do 1/4 power one that's nice. Alright, this will work. X to the 4th minus 6x squared plus 5 equals to 0. Sorry. So that last problem was silly. Hopefully you remembered that I just did that problem and I'd already forgotten. So, solving by factoring. I know that my first have to be a couple of x squareds. My signs have to be a couple of minuses. My last have to multiply to that positive 5, add to the 6. I get minus 1 and minus 5 to do that. Once I get it factored, I set the factors equal to 0. And the stuff that makes the last problems harder is this step, setting the factors equal to 0 and knowing what to do. So for the x squared minus 1 equal to 0, I add 1 to get x squared equal to 1. For the x squared minus 5 equal to 0, I add 5 and get x squared equal to 5. And then I do square root plus or minus square root. I get x equals plus or minus 1, and x equals plus or minus the square root of 5. I'm going to check each. The ones are going to be easy. For the ones, I'm going to go 1 to the 4th minus 6 times 1 squared plus 5 and see if that equals to 0. And then I'll change the 1 to negative 1 and make sure that works as well. So easy part of the checking. 1 to the 4th minus 6 times 1 squared plus 5. I get 0 for that. So I've checked the 1. Now I'm going to confirm the negative 1 works by getting into the parentheses, putting a negative sign in front of the 1's. And it works. So I've checked both of these. Both the 1 and the negative 1 is simplified to 0 equal to 0. Now I'll do the 5's. The square root of 5 to the 4th minus 6 times the square root of 5 squared plus 5. Does that equal to 0? So I'm going to give that a go. Parentheses, square root of 5 to the 4th minus 6 times the square root of 5 squared plus 5. That gives me a checking. And I'm going to just back up, change the 5's to negative 5, or the square root of 5's to negatives. And it checks as well. So I've checked all 4 solutions reasonably quickly because I didn't have an I. So my answer is going to be x equal plus or minus 1 and plus or minus the square root of 5. If you bail on me now and don't watch me do one more problem, it's okay, because this is in the bottom section. What's test worthy are just the problems with the x to the 4th and the x squares. Wouldn't hurt to watch 24. It's the easiest of the next problems. Negative exponents aren't pleasant, but I can deal with them. So if you're watching, thank you. If you're not, it's okay. So I'm going to solve this by factoring. Again, the exponents are a multiple of 2 apart because negative 1 times positive 2 is negative 2. So I can do regular factoring as long as the x gets the exponent of the middle term. And this is going to factor into a plus 8 and a minus 1 because 8 times negative 1 is negative 8. 8 minus 1 is positive 7. Now I'm going to go x to the negative 1 plus 8 equals 0. X to the negative 1 minus 1 equals 0. The x to the negative 1 is really messing me up. X to the negative 1 is the same as 1 over x to the first, or 1 over x. And having it written as 1 over x is going to make it easier to solve. I'm going to a minus 8 from both sides in this one, plus 1 from both sides in this one. I get 1 over x equals to minus 8, and 1 over x equals to 1. I like solving by cross multiplying, so I'm going to set this up for cross multiplying because I have a fraction. And a nice way to solve a fraction problem is set it up for cross multiplying. So I set this up for cross multiplying, and one direction I get x times negative 8 is negative 8x. The other direction, 1 times 1 is 1. Then I divide by negative 8 and get x equals 1 over negative 8. I'm going to move that negative up to the numerator because it looks better there to me. And the other cross multiplying, I get 1 times x equals 1 times 1, which is x equal to 1. I think these are the two solutions. I'm going to check them right up top. I'm going to see if first negative 1/8 to the negative 2 plus 7 times negative 1/8 to the negative 1 minus 8 equals to 0. So check that quickly. Parentheses, fraction, negative 1 over 8, parentheses, up arrow, negative 2, plus 7, parentheses, fraction, negative 1 over 8, parentheses, exponent, negative 1, minus 8. Hopefully I see 0. Beautiful. So I've checked the negative 1/8. Now I'm going to check the 1 by seeing if 1 to the negative 2 plus 7 times 1 to the negative 1 minus 8, and make sure that's 0. Because I don't want to write answers down that I don't check when it's not that hard to check. So 1 to the negative 2 plus 7 times 1 to the negative 1 minus 8. I messed up here because I had the minus 8 in the exponent. Let me delete this. Minus 8 properly. And I get 0 equal to 0. So both check. So for an answer, I'm going to write x equal negative 1/8 and x equal to 1. If you're interested in learning how to solve the problems with the fraction exponents, oh, heck, I'll do one. Let me just do this one. Again, easy factoring. I get two parentheses. The first term has to be an m to the 1/3. Last have to multiply that negative 4, give me that positive 3. They're going to be positive 4 and minus 1. So I'm going to get m to the 1/3 plus 4 equals 0. M to the 1/3 minus 1 equals 0. The m to the 1/3 power is hard to work with, but I can write it as a radical. It's going to be the cube root of m to the first plus 4 equal to 0. The cube root of m to the 1 minus 1 equal to 0. I'm going to minus 4 and add 1. Get the cube root of m equal minus 4. The cube root of m equal to 1. I'm going to cube to get rid of a cube root. You don't plus or minus when you cube to get rid of a cube root. On the left side, cubing cancels out the cube root, gives me the m. On the right side, negative 4 cubed is negative 64. Next side, cubing gets rid of the cube root, leaves me with the m. 1 cubed is 1. These you can check, they'll check. Again, those won't. The negative exponents and the fraction exponent problems from the bottom section, absolutely, you don't have to worry about those being on the test. In this problem, I get fifth roots and I have to do fifth powers, but I won't bore you with that. And thank you if you made it this far. So we're done with chapter 5. Next thing we need to worry about is the review. And once we get the review done, we'll be into our last chapter because we end with chapter 6.